Assalamualaikum and good morning. Today, me and my friend will be presenting the practical exercise 2 for the subject enterprise network. Our lecturer is Sesha Nazmi. My name is Arif Aiman and my teammate is Ahmad. So the objective is to create a network device documentation comprehensively for effective management and troubleshooting. So to create a document that is effective for when we need to do our management work or if we need to do any troubleshooting step. So step is first we need to discover the attached device. This discovery tool, for example, show CDP neighbors or manual testing to identify all devices in the network so that we can see and identify the devices that are in that network. So for example, we show CDP neighbor for router 1, especially router 1 is not enabled. And same goes for router 2. You can see the CDP neighbor and there is no device, no local device. Nothing is in the neighbor. Same for R3, CDP is not enabled. R4, no device. S1, no device. S2 is no device. If there was a device in the CDP neighbor, will be shown on the list. So for example, I have S3. Show CDP neighbors can see the CDP neighbor for S3 is R2. So with the local interface gigabit internet 0/2, and also all capabilities are is for router, you can see in the capability codes. And for S4 is not enabled. And then we got the switch MLS. As you can see, the CDP name switch MLS is R4 for 4 different type, and then the capability is router for R stands for router. Like each device IP address matters name model and host. So you can see the PC1, you got the device model, you got the port that is available for PC1 and the IP address and the default gateway. Same goes for the letter 1. So this PC1, this letter 1. You can see it's just PC is laptop PT, this one is PCPT. Same goes for PC2, PCPT, the IP address, and then same goes for PC3, letter 2, letter 3, and PC4. PC5, for example, you can hear this default gateway, letter 4, and then for server, instead of letter of PC is server PT. As you can see, it has only one port, facility net 0, the link is up, and the IP address and the default gateway as well. And same for SC4 server, and then we got S1 for this device name S1 custom device model is 2960 ISIS, and then also name is S1. You can see the different port that is available, the VLAN, and you can see which port is active or which port is not active. So for example, FastNet 0/24 1 is up, and FastNet 0/1 is up, and then the rest is down. Same for S2, and then same goes for S3, S4, and then for SMMLS, switch MLS, you can see the different different ports that is active, that is up or down. So that standard 0/1, 0/10, 0/22, gigabit internet 0/1 is up. With the VLAN, you can see the VLAN information. For example, 0/fastnet 0/9 is 90, fastnet 0/10 is 100, fastnet 0/11 is 110. We need to test the connectivity and modify test configuration using pin or test between all devices, so not the external device, not end-to-end device. So we need to test the pin. So R1, PC1, so we see the information earlier. So we are on ping 192.168.10.2 for PC1 IP address. For letter 2 is ping 192.168.22. As you can see, the ping is both successful. Same go R1 to letter 3, ping 192.168.32. So this the ping successful means there is communication between these two devices. For example, letter 3, the ping is unsuccessful, which means that R3 cannot communicate to letter R1 cannot communicate to letter 3. So and then the R1 to PC2, it shows that R1 can communicate to PC2 by pinging, and then you can see it's a cell phone. The self is 100%, and that is R1 to PC3. As you can see, same like the letter T is a cell phone, which means there are no communication between R1 to PC3, and then to R1 to server 3. As you can see, is cell phone, so that means there is communication. So I want to PC4 is a cell phone, I want to PC5 as a cell phone, I want to server 4 is a cell phone, and I want to laptop 4 is a cell phone. You can see, so you can see that it doesn't mean that all these devices are connected, that can communicate with each other. There are some devices that cannot communicate with each other, as you can see from the example here. And then we need to ping into end device of PC1, ping 1 and 2 and 3 and 2 request time, which means the ping is they cannot communicate. Now, if there was some like if the other device didn't allow it, for example, it didn't allow access for it to communicate, it will come out different result, such as you get a reply, but then the station host unreachable. So that means that they can communicate, it just doesn't allow it to communicate. So when you get a request timeout, means that it is completely unreachable, cannot communicate at all. So on top of that, cannot communicate properly. So for example, our PC2, it does communicate, but it's not 100% communication, it's only 80%. Same goes for here. So it's 80% here, 80% here. So I want to PC2, I want to server 3, I want to add server 4 is unsuccessful. As you can see, when to look at the connectivity result, I highlight any failed link. So you can see here, successful, successful, successful. Then we do place it. Then show LP, you can see the protocol, the address, and the interface which is on. Show IP LP as well for to show it as well. And I need to analyze the default gateway configuration. So I need to see the configuration for the default gateway. So I want to do that. Firstly, we need to access all the slash switches and replicate with interface configuration. We need to check the IP address, VLAN, subinterface data, and port status. Highlight any missing or incorrect configuration. So R1 is shown the config. As you can see here, there are different port and the IP address. For example, the interface gigabit internet 0/0 does not have an IP address, but the 0/0/0.10 does have an interface, same with 0.21. All these have an interface. And then we need to show the IP route. So you can see the different IP route. So the route that it goes to, the like a travel path. So as you can see, on the left side we have the code. So each letter stands for, for example, C. So you can see C stands for connected. So that means that 10, 10, 10 is directly connected to 0/0/1/0. We show you the connected or not. For example, here is local, and then show VLAN diff. We show the different VLAN. For example, VLAN 1 is default VLAN, but it does not have a active port here. And then you got show interface G/0/1, which means that it will show the information, the more detailed information about the interface. So show interface G0/0/0, we show that it is up, the laboratory is up, and then I will see the full duplex, got the 5-minute import rate, the different information here. 0 lost carrier, 0 no carrier, such and such. And to got show on the config. For R2 as well, same comment shown on the config. You can see the different IP address and the different gigabit internet. You can see which IP address is assigned to what interface, and then here show a build. It will show the different connection codes, and then if it's local or connected or if it's static. Same code. Show VLAN brief, show the VLAN for R2, see if there's any active port or any of those VLAN. We show the 0/0/0 and see the information on the interface. Then see the different information on different interface. You can just change the interface. So as before, we show show interface G0/0/0. Now we put show interface G0/0/1. And same goes for the RT show running config different IP address. For example, here this one has an OSPF, so the router ID is 3.3.3.3. You can see the network, the different network. You can see the IP root. For example, here got IP root 0.0.0.0.0.0.0.10.31. So show IP root. You can see here it's the configuration here. It will show on the IP root like below here, like here. So S, it means static, and the candidate default, so it goes 0, 0, 0, 0 via 10.31. So that means it goes 0, 0, 0 through 10.31. Let's show VLAN brief. You can see here no active port. If there was an active port, there will be shown different ports on the ports area here. And then show interface 0/0/1, G0/1 to show the information on the interface. For example, this one has 400 packets output. So show interface it gives the value. You can see here. This one has a packet output. This one does not have a packet output. So running config here for R4 as well. You can see the different interface. If this the VLAN, you can see the router OSPF. Then see the show below here. You can see this does be connected. You can see O here stand for OSPF here. You can see that is the OSPF is there. R4 show VLAN with no VLAN is active. The VLAN is active, but there are no ports here. And then you can show interface G0/0/0. Show interface here. Same again. Then 0/0/1/1. 5-minute input, 3 output, 420 packets output. Then you go for S1 here. You can see here. This one as VLAN, so switch port as a VLAN 10. So you can see that through the show running config. You can see that there are VLAN here. If you scroll down here on the show IP interface, you can see there's VLAN 1. That is down, but you can see 0/1 is up. Same with faster 0/1 and faster 0/2. You can see the show VLAN. This one means before that when we see a VLAN, you can see we create the different VLANs and we show up on the show VLAN brief. You can see the VLAN 1 has like few ports assigned to the VLAN 1. So F8 4, 5, 6, 7, 8 until like show different different ports that is assigned to that VLAN. And I show interface trunk and show the trunk. For example, 0/1 VLAN allows on that trunk is 1020. Same equals here. So this one so that the VLAN is expecting equals to go 40 straight and not boom. And then the VLAN is allowed and active in the management domain. So S2 here, shown config on S2, you can see the VLAN 3040 assigned to what IP address, to what interface, and then you can see the initial interface is 0/1 is up. Same with 3 first step 0/3 and 4. So you can see this different information through this show command. Can show interface trunk. You can see for this one has a bit more than the earlier we saw before. This one 30, 40, 50, and 60 allow on trunk. And then we go into S3 show and config. You can see all these different port. You can see there are nothing happening to this port because we do not assign any configuration to it. But we did do some configuration on 0/5 and 6. We did some VLAN configuration, switchport access VLAN 50, switchport access, switchport access VLAN 60, switchport access, switchport IP interface brief. You can see that the server goes up, 056, and show VLAN brief. You can see that we assigned those VLAN earlier on 50 and 60, and we'll show you on here 50 and 60. Same configure, show interface string, give me the 0/1 50 50 allows on trunk, span key for this three and boom, and then we get show and config for F4 as well. See that first step 0/7 and 8 does have VLAN 70 and 80. So if we go down to show VLAN brief, F8 0/7 and 8 is assigned to VLAN 70 and 80. And then you got show interface trunk. You got here, got a few more, got one until 1005. So we see there's a range of VLAN 1 until 1005. Instead for 1.1, you can do range. Further, but this one, there is no range because you must, like, for example, it does have 10 until 110, but it does have, yeah, so the switch I'm not sure when it won't fit here. This one has three different VLAN. So on equation that 9 is 90 VLAN 90, Ethernet 10 is for VLAN 100, Ethernet 11 VLAN 110. You can see show up interface brief here, show VLAN brief as you can see here. The FA source of line is 90, 10 and computer 2 is on 100, and FA11 is on VLAN 110. So you can see the port that is active on that VLAN, and then get the check interface now. Now we're moving on to for troubleshoot and configure. I will pass this on to my teammates as Adam. Okay, so continuing where we left off. So question for number 4, troubleshooting and reconfigure. Number 1, identify and fix all the configuration errors found in previous step. So one of the errors that we found is at PC1, which is the default gateway 192, 168, 10, and 254. But the correct default gateway should be 192, 168, 10, and 1. After that, we put the command of no shutdown to the interface of G01, and then it should be like this. It should be up. Okay, then after that, this is the command that said that G00 no shut, and also G01 no shut, and that's how what it should be. Okay, so after that, there is a cabling problem around the right side of the topology, which is around the PC5 and laptop 4. So PC5, it says that fast Ethernet 1, and then laptop 4 says fast Ethernet 22, but the server 4 is fast Ethernet 10. So it should change to PC5 fast Ethernet 9, and then laptop 4 fast Ethernet 11. So it should be somewhere like this. Alright, because if you don't, when you try to ping, it won't reach, it become unreachable. Okay, so after that, we're gonna check each of the devices, router and switches, whether the CDP has been configured or not. So for our one, we do the show CDP neighbors, and it says the CDP is not enabled, means that we have to enable it later. So we're gonna put the command CDP run. After that, R3 is also the same as R1, which is the CDP is not enabled, so we also put the command CDP run. Also, the same goes for switch 4, which is no enable CDP. So of course the command should be CDP run. Okay, after that, we go to router 2 to see the IP SPF route. So we put the command show IP SPF INT brief. So as you can see, there is 4, which is the first one, gig Ethernet 0010, and then the 2 gig Ethernet, and as you can see, there is different type of IP address with the same subnet mask and certain that different subnet mask. Okay, then after that, so this is the output that we got after we put this command below, which is, so we must configure the router OSPF so that it can communicate in between. So the command would be router SPF1, and then router ID 2.2.2.2, and then there's network 192.168.T0, and the 0.0.0.2555 area 0, and then 192.168.40, also the same subnet mask area 0, and then network 192.168.50, also the same subnet mask, and also the same area 0, and next network 192.168.60, also the same subnet mask and also the same area, which is area 0, and then lastly network 10.10.10.10, the subnet mask would be 0.0.0.3 area 0. So after that, we must correct the we must correct the encapsulation IP address for the gigabit Ethernet 0.0.8, because when we first put the show IP ID brief on the router tree before it's been configured in this command, the the gigabit Ethernet 0/0.80 says that it's unsigned. So what we must do is put the command, we enter the gigabit Ethernet interface G0/0.80, and then enter the command, which is IP address 192.168.80.1.255.255.255. And then since it's already up, there's no need to shut down, so we just need to put the IP. Okay, so after all that is done, there should be no more problem, and we must verify whether the successful or not. Okay, so PC1 to laptop 1, we ping from PC1 the IP of laptop, the IP of PC, we ping from laptop 1, we ping from PC1, so the IP will be 192.168.20 and 2, which is, as you can see, is successful. And then PC1 to PC2, also successful. The IP of PC2 would be 192.168.50 and 2. And then PC1 to PC3, also successful. The, the IP address of PC3 is 192.168.60 and 2. And then PC1 to PC4, PC4 IP address would be 192.168.80 and 2, and it also show that it's successfully have been pinged. And then PC1 to PC5, the PC5 IP address would be 192.168.90 and 2. It also work. Then PC1 to laptop 2, we ping 192.168.30 and 2. And for the PC3, for the laptop 3, 192.168.40 and 2. Both of it is working out well, successful. And then lastly for the laptop would be the top 4, which is 192.168.110 and dot 2. It also pinged successfully, there is no error. And then from PC1 to both the server, which is server 3 and server 4, server 3 IP address will be 192.168.70 and 2. Server 4 will be 192.168.100 and 2. And luckily all of them is working properly and have no error, have no unreachable host and such. And then we must show the question asks for update configuration and confirm stability. So after we put all the commands, and this will be our final just checkup, we put the command of show CDP neighbors. As you can see that there is a device which is router 2, router 4 and router 3, which is very different from the first time we do, like way before at the earlier question. And then also do it at the router 3 and also switch 4 to see what are the device that exists in the such devices. Like let's say router 3, there's R1, and then for S4, after we put the show CDP neighbors command, there is R3, there is 3R3, because there are 3 type of port ID. So lastly, we create the documentation table. So this is the table that we collected after the thorough research from the topology and after finish preparing all of it. So this is the end device IP address. We got PC1 192.168, 192.168.10.2, and then this is the gateway would be 192.168.10 and 1. Then let's say I just explain it briefly. We got PC1, laptop 1, laptop 2, laptop 3, PC2, PC3, server 3, server 4, PC5, server 4, laptop 4. So I'm sorry, it's a bit unorganized, but all of the IP address, the gateway, the switch port connected to, and also the VAN is correctly put inside the table. And then for the router, we got 4 router. So the SPF ID would be for the first router 1.1.1.1, and then the router that connected to is switch 1, router 3, router 4. And then in the interface IP, this is the one that they show for G0/0/0.10. The IP will be 192.168.10.1, and then for the G.20 will be 192.168.20.1, and for the G0/0/1 will be 10.30.30 and 1, and serial 10, 10, 10, 10 and 1, and lastly for the router 1, serial 0/1/1, 10, 20, 20 and 1. And then router 2, the SPF ID will be 2.2.2.2, and the rest will be also the same, like let's say router 3, 3.3.3.3 and so on. So as you can see, this is the connector 2, switch 2, switch 3 and R1, and also says for this one what the IP address interface that we got. So I'm not gonna waste your time on explaining all this, because I'm sure that I already put all of the correct SPF ID, interface IP, and also the switch port I connected to. I mean the device I connected to. And then lastly, we got for the table is switches. We got five types of switches: switch 1, switch 2, switch 3, switch 4, and also the multi-lane switch. So the function will be the access point, all of the access point except for the last switch, which is multi-lane switch. And then there is the port and plus, which is for switch 1, as you can see, for Ethernet 01 is plan 1, plan 10, for Ethernet 2, plan 20, for switch 2, for Ethernet 1, plan 30, for Ethernet 2, plan 40, switch 3, and so on. Let's keep going up and up. And then for the trunk, for switch 1, R1, G0/0/0, R2, G0/0/0, and then switch 3, 2 G0/0/1, S4, 3 G0/0, and multi switch will be R4 G0/0/0. Okay, I believe that's all from us. Thank you so much for spending your time for looking out for us. Thank you so much, sir and madam. Sorry for if there's any less and bad things that the way by the way we explain it. Hopefully you can accept the presentation that we do. Thank you very much. Assalamualaikum.